Now, on this channel, we talked about many database backend options for your app. We talked about Firebase, we talked about Supabase, we talked about Pocketbase, and we also covered many other amazing database backends. But in today's video, I'm going to be showing you an amazing database backend that you can use for your apps. It is super fast, super lightweight, and 100% free, and you can get started right away. Now, before we get started, as always, all the apps and all the resources that I'm going to be demonstrating in today's video can be viewed and or cloned from my Patreon page, and you can learn more about our amazing Patreon community via the link in the description below the video. Now, the database engine that we're going to be covering today is called SQLite, and it's not only one of the most used database engines in the world, it's also one of the most simplest database engines in the world. Okay, so here we are at SQLite.org, and it's spelled as SQLite. And as you can see, SQLite is, among other things, a high reliable, full-featured SQL database engine. SQLite is the most used database engine in the world. SQLite is built into all mobile phones and most computers and comes bundled inside countless other applications. So it is a super reliable, super fast, and a super lightweight database engine in the world. And in fact, FlutterFlow, which is my favorite no-code building tool, recently added SQLite as one of their supported database engines. And so you can head over to FlutterFlow documentations and you can read more about SQLite and the kind of things that you can do with it. And before I explain to you how you can make SQLite as your app's database engine, let me show you a quick app I built that uses SQLite as its database engine. And so here we are inside of FlutterFlow, and this is a simple app that I built that uses SQLite as its database engine. And so before I show you how I actually built this app, let's go ahead and run this app so that you can see how it works. Now, currently, FlutterFlow supports SQLite for mobile applications only, not web apps. And so what we need to do is we need to click here and we need to download the code. Once we do that, you're going to be seeing this code here. So I already downloaded the code. And as a result, I can run this code on a simulator. So like an iOS simulator or an Android simulator. So what we're going to do is we're going to click here and we're going to select one of my simulators here. So I have this iOS simulator and I also have this Pixel 7 simulator. So we're going to select the simulator here. That's going to go ahead and launch an Android simulator. So as you can see, we have a fully functioning Android simulator, which is a Pixel 7 phone. So it's up and running. And so now what we can do is we can come in here, run, and we can actually run this app, and that's going to execute it on this simulator device here. All right, so our Flutter app has loaded in our Android simulator. And as you can see, this is a very, very simple to-do app that uses SQLite as its database backend. And so we can mark one of these nodes as completed. And when we do, it goes down to the second list here. So I can mark this node. I can also uncheck it. It's going to go up. It's going to go back to this to-do list, basically the nodes that need to be completed. We can also delete a node. When we do that, that node has been deleted. We no longer see it. And we can also create new nodes. So I just created a brand new nodes. And here we have 4 new nodes that we've just created. We can mark them completed. So there we see it. And now our nodes are completed, and we can also uncheck them if we've decided that we still need to complete these nodes because they weren't finished in the first place. And now that we've looked at them again, we can check them again. And so this is a very, very simple demo, but under the hood, there's lots of things happening. There's lots and lots of operations. So for instance, we can create a new node, we can modify existing nodes, and we can also delete existing nodes as well. Okay, so now that you've seen this demo, let's head back into FlutterFlow so that I can show you how I've built this kind of app using SQLite as the database backend. So here we are back inside of FlutterFlow. And the first thing that you need to do is you need to actually set up your SQLite database. And so if you head over to settings, you can scroll down to integrations and you're going to see a new setting here called SQLite. And if you select this, you can enable SQLite. Once you enable SQLite here, the next thing that you need to do is you need to upload the actual database file. Because remember, SQLite is extremely lightweight. It stores everything inside one file. There are no servers, there are no instances to host, there's no, accounts, third parties. You don't need to have a server somewhere. It's just one file. And once you include this file with your app, this file, this database file, will be included in the apps that your customers are going to be downloading. So if you end up building a web app, you're going to have this file included as part of your app. If you end up building an iOS app, you're going to have this file included as part of the iOS app. If you end up building an Android app, you're going to have this file included with your Android app. So it's a very, 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 very lightweight system. There's no servers, there's no API calls, there's nothing of that sort. And trust me, you can build some very, very high traffic apps that use this just file as their database backend. Now, FlutterFlow does not give you a way to create this file inside of the UI. You need to create this file somewhere else and then upload it to FlutterFlow. And so once you have this file, you can simply click here and upload it. Okay, so how exactly can you create this file? Well, there's lots and lots of tools that allow you to create such files. And so if you head over to FlutterFlow documentation and you search for SQLite, they recommend a tool called SQLite Browser. This is a great tool that you can use. Now, if you're using a Mac, then I can recommend a tool called Table Plus, which is a great, easy to use tool that makes creating these tables very, very easy. And so here's my database file that I created. Here we are using Table Plus to browse our database that we store in just that one file. And as you can see on the left-hand side, we have just one table called notes. And on the right-hand side, we have the records in this table. And as you can see, we only have two records representing two notes. And the schema here is that we have an ID, name, and done, which are the fields for each of the records. And the ID is the primary key, and so that gets incremented for each new record. The name is the name of the node, and done is like a flag that represents whether a specific node is completed or not, right? So 0 means that it's not done, 1 means it's done. This is essentially a fully functioning relational database, just like the database that we use when we use Supabase. But whereas Supabase contains a lot of these other components besides a database, things like authentication, storage, edge functions, etc., etc., SQLite is just a database. It's just a database and nothing else. And so here you can create more tables, you can create views, you can create relationships between them. You can have one-to-one, one-to-many, many-to-many relationships. All the relationships that you can create with Supabase. You can do all of this right here in SQLite. Now, if you're just starting out, you're not going to have this database like I do, but it's very, very easy to create one. You can simply go into File, New Workspace here. Then you want to click on this plus and you want to select SQLite. So we're going to select SQLite, click on Create. And here you can give it a name. So let's say we're calling it new DB. Next, you want to select a directory where we're going to be storing our database, because all it is just one file. We're going to select this database here. We're going to give this a database name. So something like new DB. Click OK. And now we have a path for this database file. Next, you want to click on Save. And now you have a brand new database that we've just created. Next, I want to double click here. And now we have a new workspace with a new database. And so you can create a new table by clicking here, and you can call it notes, press enter, you have notes, and then you can create multiple fields. So let's say you want to do name, press enter, then you want to do, let's say, done, enter, and you want to give it a data type. So name, I'm going to say name is a text, and done is an integer, and then you can add more fields if you want. Next, you want to click on data, and you can create new records. Okay, so I'm going to say this is name 1 and this is not done. I'm going to say 0. I'm going to say name 2 and I'm going to say not done. And now I have a table called notes with 2 records. Now, once you finish creating your database, you want to click here, you want to upload, and then you want to select your database that you've just created using a third-party tool, whether it was Table Plus or something else. And here you want to select it and upload it. Now, once you've uploaded your database, the next thing that you need to do is you need to create read queries as well as update queries. Now, if you click here, you're going to see that I have 3 read queries that I'm going to be using in my app. And so when you're building your app, you need to ask yourself, what are the ways that I'm going to be pulling data from my database? Because all of this you need to define in advance. And so in this simple to-do app, I have 3 read queries. The first is a query that gets all the nodes. The second is a query that just gets the nodes that are not completed. And the last but not least is a query that gets the nodes that are completed, okay? So if you click here, this is my first read query, okay? So I gave it a name, I called it get all nodes, and here I need to specify the actual SQL code for the query, okay? So in this case, I'm saying select everything, asterisk means everything, from nodes, and I'm also doing ordering, right? Because I want my nodes to be ordered. So I'm saying order by name here. Now, I can also specify a variable that I can, have in this query that I can pass during runtime, right? So anytime you are doing some kind of operation in FlutterFlow, whether it's an API call or any kind of operation, you typically can create a variable that you're going to be passing via the app as the app is running. Now, in this case, I don't really need a variable, okay? This is going to be a static query that's going to be the same regardless of what happens. Now, in this section, I need to specify my output columns, and this is going to be the data that I'm going to be using in my app. Now, this query here gives me back all the columns from all the records, but I still need to specify the columns that I'm interested in because I'm going to be referring to them in my app. And so in this case, I'm saying I'd like to have the ID available, I'd like to have the name available, and I'd like to have the done available. And that way I can make use of this data when I'm displaying things in my UI. Okay, so now I can hit save. And that's my first query. Now, the second query, get all not done, it's very, very similar to the previous one, except here I have a filter where I'm specifying that done is equal to 0. Okay, and this is essentially going to give me all the items that are not done because I have it set up that when done equals to 0, it's not complete. But when done is equal to 1, it's complete. Now, in Supabase, you actually have a Boolean type that you can use. That's going to be true or false. In SQLite, you do not have a Boolean type. And so you have to resort to using integers, which is absolutely fine because integers are able to represent true or false values very, very well. And so this is a query that filters our nodes based on where done is equal to 0, and everything else is still the same. Everything else is the same. And last but not least, it's the same query, but we're saying done is equal to 1 this time, meaning that we only want the nodes that have been completed. Okay, so we have 3 queries that we're interested in, right? And unlike, with some of these other database engines such as Firebase, Firestore, or Supabase, or some of the other ones, the way that FlutterFlow integrates with SQLite is you need to define them in advance. Okay, and so these are the 3 queries, right? The 3 types of data that I'm going to be interested in my app. And so that's why I created 3 different queries. Now, if we head into update queries, we are going to have 4 update queries that I'm going to be using throughout my app. Okay, so I have one is mark completed. So if we click here, this is where we are going to be marking a node as completed, okay? And the way you do it is you're using this update SQL statement. And if you're not familiar with SQL, you can kind of read more about it. But the way that SQLite works right now is you need to write your SQL statements. But thankfully, they're really, really easy to learn. There's like 4 main ones. There's select, insert, update, and delete. That is the 4 main ones that you need to know just to keep it simple, and you can use SQLite as your database backend. And so the name of the SQLite query is mark completed, And what we're doing is we're updating nodes. We're setting done equals 1, where ID equals to a specific ID, because we don't want to set all the nodes to done. We only want to set for that specific node. And here I am making use of a variable, right? As you can see, I'm saying ID equals to $, curly braces ID. And this is going to be replaced by this variable that we're going to be passing inside of our app, as I'm going to show you in just a second. So this is all that we need for a query that updates a record as done. It just sets it done equals to 1. The next query is marked not completed. So the same query, except it just sets it to 0. So if it was done, it's going to be 0. Okay, so it's going to move to the other list. It's going to move above to the first list, essentially, in the UI. Next, we have delete item. And here we're using delete from nodes, where ID equals to the ID. And we're also going to be passing a specific item, right? Because we need a variable, right? We don't know ahead of time which specific item the user is going to be deleting, and that's why we need to create a variable, because this is a dynamic operation. Okay, and last but not least, we have create new record. Okay, and this is the simplest query overall, and we're saying insert into nodes, and we're going to be passing name and done, right? So our nodes can have 20 different fields, but if we only care about setting name and done, then we need to explicitly specify them. So we're saying we're going to only be passing name and done. Okay, so even if it has 50 fields, we're only going to be setting these 2 fields, and the values here are going to be static. So regardless, what kind of item that we are creating, the name is always going to be new item. Okay, new item, and done is going to be 0, which means that it's not yet completed. Okay, and so as a result, we don't have any variables. Okay, so hypothetically, for this new item, you can ask the user, what do they want this new item to be called? And if you're going to be doing that, then you need to create a string variable and pass it, set it here. And that way you can have, your system, your app, ask the user for a variable, and then you can pass it to this operation here. All right, so at this point, our SQLite configuration is complete. There are 3 things that we needed to do. The first one was we needed to create our SQLite database file. We needed to upload it here. Next, we needed to create the read queries. Okay, we needed to ask ourselves, what are going to be all the ways that we are going to be retrieving this data to display to the user? And here I have 3 different queries representing all the different ways that we are going to be retrieving this data. And last but not least, we need to define the queries that are going to be writing the data, right? So creating new records, updating existing records, or deleting existing records. And as the case is here, we are doing all of these things, right? So we are updating existing records using these 2 queries. This query deletes an existing record, and this query creates a new record. And now that we've set up our SQLite, we can start building the actual app. And if we head over to our UI builder, you can see that we only have 1 page. This is a very simple single page app that does everything on that 1 page. Now, the first thing that I want to show you is we have 2 lists. Okay, so we have lists called list not done and list done. So list not done displays all the nodes, all the to-do items that are not done. And you can select this list here, come back here, and you can edit it. And here you can select the SQL query. Now, when you select the SQL query, you're going to be shown all the queries that you've set up as read queries, right? And that is why with FlutterFlow, it's important to separate your queries, because the read queries are going to be displayed anytime you need to display them, right? So in a list or any other situation where you are displaying the data. Whereas write queries are going to be displayed as part of actions, okay? So as an example, if the user clicks here, we are going to toggle the checkbox. And so in this list, if they click on this checkbox, we want to toggle it on. And so this checkbox has an action. And if we open it up, we're just doing toggled on. And so here, as you can see, we're doing a backend call. And here, you're only going to see the update queries, right? Because this is an action. And with actions, you're doing something to your data. You're not displaying your data because that is done in the UI. Actions are updating your data. And as a result, FlutterFlow can display only the actions that you've defined as update actions, right? Essentially, write actions. And here you can choose, do you want to mark completed, not completed, delete item, create new record? And here, what are we doing? We're marking it completed, because this is what happens when the user clicks on a checkbox in the not completed list. We want to mark as completed. And we also want to pass the ID, because if you recall, we have one variable that we depend on, right? That the query depends on. And this is why we see this variable pane, and we can select this ID, and you can simply select it from that list. Remember, we have that list, which is not done. And here you can just select ID. And now this ID, that current item that the user clicked on, that current item from that list, is going to be passed here. And we're going to know which ID, which specific item that we're dealing with, so that we can pass the right ID to the query and perform that update. So very, very straightforward. And also this delete button, right? So this delete icon here, we're going to open it up. And we also have a backend call. And this is delete item, right? Same thing, except we select delete item here, and we're also passing the ID, okay? So whatever the ID is, we know the specific to-do item the user is dealing with, and we can pass the ID, and that's going to pass it to the query. And that way that delete, from table, etc., will be executed correctly. And it's going to delete the item. Now, this icon here allows us to create new to-do items, okay? So a very, very similar behavior. Backend call, this time we're doing create new record. We're not dealing with any variables, okay, because we don't really care what the name of the record or anything else. We're just going to create a default record, just going to say new note or new item. And that's all we are doing. And I also have similar behavior for this list. Now, this list here is actually pulling all the done items, okay? So if the user clicks here, that item is going to be done, and that item will automatically appear in this list. Now, if the user clicks on this checkbox here, we are toggling it off, right? Because the items in the bottom list are going to have the checked by default, right? So if the user clicks on the check mark, we are going to be toggling it off. And in that case, we need to mark not completed, right? We want to, tell the system that this item is no longer completed. And when we do that, this item is going to move from this list to this list. Essentially, the reverse behavior here. Now, remember, you won't be able to test out this app inside of FlutterFlow because the SQLite engine does not support web apps right now. And so what you need to do is after you finish building the app, you need to download the code and you need to run it on an emulator or on a real device. And this means you'll be able to test out your app on an iOS simulator or a real device, on an Android simulator or a real device, or as a desktop app. So I can simply head back here. I can select macOS desktop here, and I can run this app. And as you can see, now I'm running this demo as a desktop app. So I can mark these as completed. I can do that. I can delete them. I can delete them. I can create a new one. I can create more new ones as well. I can mark them as completed. And so as you can see, everything works just like how it worked on an Android simulator. And if you can get it to work on an Android or an iOS simulator, it's also going to work on a real mobile device as well. Now, if you're a member of our amazing Patreon community, you're not only going to get access to this FlutterFlow app here, I'm also going to make available the actual source code, which means that you can test out your app on mobile simulators or on real mobile devices if you have access to those as well. And that's actually one of the many perks of being a member of our amazing Patreon community, because not only are you going to get access to this app, you're going to get access to all the apps that I built on this channel. And these are all kinds of different apps that do all kinds of different things. And so regardless of what you're trying to do, what kind of app you're trying to build, you'll be able to view and or clone pretty much all my apps. And there are more than 150 apps that I have on Patreon that are available for you to clone, to use, to learn from, to leverage, whether you are building an app right now or are planning to build an app in the future. And that's not all. When you join our amazing, rapidly growing Patreon community, you're also going to get access to extra content. So things like Q&As, live streams, behind the scenes content, as well as our Patreon supported masterclass series where I do deep dives on specific topics that the community wants to learn more about. And in fact, just a week or two ago, I did a very, very exclusive deep dive on a very, very promising tool that many of you have wanted to learn more about. I also answered many of your questions. And in fact, I answered all the questions that I received in one of the Q&As as well. And so if you want to have access to all of this amazing content, whether this is content that I'm going to be doing in the future or content that I've done in the past, it's all available or will be available on our amazing Patreon community. And plus, when you join our amazing Patreon community, you're going to be supporting this channel and supporting my work. And so if you're getting any amount of value from these videos, from these tutorials, from these apps that I'm building, then you're going to get even more value as a member of our amazing Patreon community. And so if you're trying to level up your no-code game, you're trying to take your no-code knowledge to the next level, then I definitely urge you to check out and join our amazing Patreon community. And you can do just that via the link in the description below the video.